myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we learn about pointers in C. So, with the topics which we will be covering in this video lecture are the definition of pointer, what is a pointer variable, then other topics like how to declare a pointer, how to initialize a pointer, and along with some sample programs, and at the last we'll see the uses and applications of pointers in programming language. So coming to the definition of pointer, so we can say that pointer is a special variable. So we have variables, but pointer is also a variable, but it is a special variable which stores the address of other variable. So let us understand. So coming to the introduction of this pointer, so in memory, so we store the information in memory. So each memory block consists of each memory. So in each memory, there are blocks of memory. In each block, 1 byte of information is stored. So 1 byte of information is, suppose this is a memory representation. So in each block, 1 byte of memory, 1 byte of information is stored. Suppose if we want to, and along with the information, there is a corresponding address available for each byte of information. Suppose this is some random address which is assigned to this byte, to this memory block. So 1000. So next will be 1001. Next will be 1002, and after that we'll have 1003 and so on. So if we want, suppose if we declare an integer variable a. So suppose if we declare an integer variable a, so in the program, so what this will instruct the compiler is, so this will instruct the compiler to allocate 4 bytes of memory for this integer variable a. So 4 bytes of memory will be allocated for this integer variable a, and a will store. So if you refer to the address of a, so we will get the address, that is the base address. So we can also print, we have seen how to print the address of this variable by using this address of operator. So if we use address of operator, after that the variable name, we will get the address of this variable a. So this variable, it will print 1000. So it will print 1000. So this is nothing but the base address. So this integer variable will occupy 4 bytes of memory. So it will display 1000, that is the base address at which this a value is stored. So if we want to, so this will occupy 4 bytes. So 1000, 1, 2 and 3. So these are the 4 bytes which are required. So these 4 bytes are required to store this integer variable a. Now, in order to point this, now if we assign to this variable some 10, so suppose we assign a value of 10 to this variable a. Now what it will do is, it will, so variable a, in that value 10 will be stored and associated address will be 1000. So that is what it is. Now what is a pointer? Pointer is a variable, you can say. It is a special variable which stores the address of other variable. So pointer, when we talk about pointer, so let us discuss it with an example. Suppose in a building, so in a building there are number of rooms and each room has a number. So if you want to go to that particular room, so we can go to that particular room with the help of the room number. So similarly, so pointer is also a variable which can point to a variable. So pointing to a variable means storing the address of the variable. So with the help of pointers, we can actually access the values which are stored in the variables. So for example, so if we are using a pointer here, so p is a pointer. Now suppose we use a pointer, so pointer p, so it is pointing to this. So it is pointing to this address means it is storing this address. So it is storing this, it is storing the address of this integer variable a. So p is pointing to a means p is storing the address of integer variable a. So let us see how to declare a pointer, then after that how to initialize the pointer. So first is pointer declaration. So what is pointer declaration? This is the syntax. So data type followed by followed by star or asterisk symbol. Then after that, the pointer name or pointer variable you can say, followed by semicolon. So here data type refers to the type of the value which the pointer points to. So now in our case, we have seen that. So if we declare a pointer, so examples we'll see later on. So here data type refers to the type of the value that the pointer will point to. So asterisk symbol, so this symbol, the variable name, it is preceded by asterisk symbol. So this tells that the variable pointer name is a pointer variable. So general variable or simple variable, we declare it as in this way. So if we want to declare a pointer variable, then we need to use this symbol, asterisk symbol. So this is also called as dereference operator or indirection operator or value of operator. For example, so this is how we can declare a pointer. So int star ptr. So here name of the pointer is ptr. So we can say that this is a pointer variable. ptr is a pointer variable. ptr is a pointer variable and it is pointing to, so here data type is int. So int means it says that ptr points to variable of integer type, or you can say that ptr points to integer value. ptr points to integer value. That means it stores the address of integer value. For example, another example we'll see, float star ptr2. So here ptr2 is a float pointer. That means it can store the address of, it stores the address of a variable which stores floating value. So similarly, we can declare other pointers also. We can declare a character pointer and so on. Next is pointer initialization. So unless and until we initialize the pointer, so it is not possible to use the pointers in programs. So once a pointer variable has been declared, so we have to assign a value to it. Pointer initialization. It can be made to point to a variable using an assignment statement. So for example, so in these different lines, so in the first line, we have declared a pointer variable, here star p. So p is a pointer variable and abc is a normal variable. When we are assigning, so abc, so we are declaring two variables. So memory will be allocated for this variable as well as memory for as we know that p is also a pointer variable. This is a special variable, so it will also have some address. So let the address of this be 2000, let the address of this be 1000. So in the computer, memory is allocated for this variable as well as memory is allocated for this variable. But p is not pointing to this any variable. So p is not storing any address. So therefore, it will not point to any value it will not point to any value. So in order to make it point to a value, specific value, so what we have to do is we have to assign the pointer with some address, with the address of the variable. Now if you write in this way, now what we are doing, we are assigning the address of ABC. So address of ABC is 1000. So if we are assigning the address of ABC, that is 1000 to the variable p, to the pointer variable p. Now with this assignment statement, so this is address of operator. With this assignment statement, now we can say that p is pointing to the variable ABC. The address of ABC is assigned to p. Now one more example we'll consider. So here integer variable a. So there are two lines. First line is integer variable a is declared. So it will store integer value only. So corresponding value is, so this is the value 10. 10 is the value and its corresponding address is 1000. Suppose this is the address of this variable. Variable name is a. Now if you declare in this way, so here star ptr is a pointer variable. So we can initialize and declare pointer variable in this way. So one way of doing it is int star ptr. So this is pointer declaration. This is pointer declaration. After pointer declaration, when we write it in this way, ptr is equal to, assign it with the address of a. Now ptr is pointing to integer value. So ptr is storing the address of a variable which stores integer value. So therefore we need to declare the data type as integer here. So these two lines, pointer declaration and initialization. So this is pointer initialization. So these two lines can be combined and we can write it in a single line. Int star ptr is equal to ampersand of a. So that is what we have done here. Now this ptr variable, a pointer variable, will point to this variable a. So suppose its value is, now its value is 1000 and its address is 2000. So these are random numbers. So we have taken them approximately. So we can visualize it in this way. Suppose, so here a is a variable and its value is 10, corresponding address is 1000. So it is stored at memory location 1000. So ptr will hold the address. Now we can say that ptr is pointing to a. ptr is pointing to a means ptr is storing the address of a. So it will have its own address. That address is given by 2000. Now let us see one program where we are using pointers. So here in this program, we have declared an integer variable num. So num is equal to 42. So compiler will allocate some memory for this. 4 bytes of memory is allocated for this. Value will be 42. Then along with some address. So next, in the next line, we have declared an integer pointer. So it is an integer pointer. We have assigned. So declaration and initialization we have done. So here we have declared a pointer as well as initialized it with the address of num. So with this statement, what it means is ptr is pointing to this num. So whatever the address of this is, so here we have the address of num. So that is ptr value will be the address of num. So it will have its own address. So here we will have the address of ptr. Now with these 4 statements, we are trying to print. So we can access the value of num by using num as well as the ptr pointer variable. So how we can do this? Let us see. So value of num is %d and then num. So this is going to print the value 42. Corresponding statement is 42. Output is 42. Now in the second line, what we are doing is we are printing the address of num. So in order to print the address of num, we are using a format specifier. Format specifier used here is %p. So ampersand. So corresponding address can be obtained by the ampersand num. Now value of, in the next line, we are printing the value of ptr. So ptr is a variable which holds the address. So value of ptr will be nothing but the address of this num num variable. So it will give the address of num variable. So here address of num and this ptr will be the same as you can see in these 2 lines. So address of num is this one and value of ptr, which is nothing but ptr is pointing to num. So it will store the address of this num variable. So both these addresses will be same. So ampersand. So ptr, since we have initialized that ptr is equal to num. So in the first line, the second line we are printing this value and the third line we are printing this value. So both of them are same. Then in the last line, value pointed to by ptr. So we can also access the contents of this variable num by using the dereferencing operator. So that is called as star. So followed by the pointer name. So star ptr. So it will give num value 42. So we can also print the value of this num variable by using star ptr, by using the dereferencing. So this is called as dereference operator or indirection operator. So by using this dereference or indirection operator, we can access the contents of num variable. So value pointed to by ptr. So percentage here, since this is pointing to an integer value, so therefore %d is the format specifier and then star ptr. So we can analyze this in this way. So star ptr is nothing but star ptr is nothing but the address of num. So so this star ampersand num means, so address of this is given by, so suppose this address is 1000. So this is the address which is mentioned here. So value, So this statement we can assume it as value at this particular address. So value at the address of num. So that is given by 42. So therefore you will get 42. Next is pointer assignment. So one more program where we use pointers here. So in this program, in the first line, we are declaring a pointer and declaring a variable and initializing it with the value 10. So num1 is equal to 10, and one more variable we have taken, num2. So its value is equal to 20. Now we have declared and initialized two pointers, ptr1 and ptr2. Suppose this address is 1000, this one is 2000. So what we are doing here is ptr1. So this will point to this one. So we are assigning the address of this num1 to ptr1, and we are assigning the address of num2 to ptr2. So this 2000 will be stored here, and now this is ptr2 is pointing to num2. So now if you print the value of num1, so value of num1, 10 can be printed by num1, then 20 can be printed by num2, and then value pointed to by ptr1. So 10 value also can be printed by using the dereference operator or indirection operator. So star ptr1. So if you print this, so star ptr1 also holds the value 10, and then star ptr2, so it holds the value 20. So it is pointing to integer value, so this is equal to 20. So if you print, so format specifier to print this value is %d and then star ptr2. Now we can also change the contents of num1 and num2 by using this dereference operator or indirection operator. So now if you change ptr star ptr1 to 30, so and then in the next line star ptr2 is equal to 40. So what we are doing here is star ptr2 star ptr1 is value at this particular address. So value at this address is assigned as 30, and value at this particular address, it is given a value of 40. So now num2 value will be 40. Now if you try to print num1 and num2, you will get 30 and 40. So in this way, by using operators, we can actually work on the values. We can also change the values. Next is another example of pointer assignment. So here we have initialized and declared two variables, num1 and num2. So num1 is equal to 10 and num2 is equal to 20. So star ptr is equal to num1. So ptr1 is storing the address. Suppose this is 1000. So it stores the address of this. So it is pointing to num1. Now we have declared another pointer ptr2 and initialized it with the address of num1. So now we have initialized it with address of num1 means now this is also pointing to the same variable num1. This will also store the address 1000. Now value of num1 can be accessed. If you try to print num1, you will get 10 here. So output of this is 10. Output of this line, this printf statement is num2 is equal to 20 because that is what the value here is. Now value pointed to by ptr. So star ptr. So in this you can, so in star ptr what value you have? You have the value 10. So 10 value will be printed. Value pointed to by ptr2. So ptr2 is pointing now to integer value that is 10. So it will also print 10 only. Now if you change, so with this statement what we are doing here is star ptr1 is equal to 30. So star ptr1 means it is storing the address of this num1 variable. So therefore it will change the contents of this. So star ptr, this value is equal to 30 now, and star ptr if you assign ptr2 is equal to 40. So output of this will be star ptr2. So star ptr2 is equal to 40 here. So ptr2 is also storing the address of num1 only. So num1 only, it will be 40. So updated value of num1 is, now the update, you can see here the output of this is updated value of num1 is 40, and then the updated value of num2. So num2 we have not changed anything, so it will remain as it is. So 20 is the output here. Now program to obtain the size of each pointer type. So we can declare syntax to declare a pointer is data type followed by star and then the name of the pointer. So here data type refers to the type of the value which the pointer is pointing to. So it can be an integer pointer. So if you write in this way, so this is a program to calculate or to obtain the size of each pointer type. Suppose if you declare a pointer to an integer type, then this is just a declaration. We are declaring a pointer to an integer type. So this is the pointer name. We are declaring a pointer to a character type. This is a pointer name. And here we are declaring a pointer to a, this is pointer to float value. And this one is pointer to character value. And this line is pointer to an, or you can say this is an integer pointer, character pointer, float pointer, and this is pointing to integer value. So this is also pointing to integer value, pointing to float value, and this one is a double pointer which is pointing to a double value. So with the help of size of operator, we can actually determine the size of each pointer type. So by using size of operator, we can find out the size of each pointer type: integer, character, float, and double. So this is the output of this program. So you can see here the size of all integer pointer is 8 bytes, size of character pointer is 8 bytes. So irrespective of the data type to which it is pointing to, it has a size of 8 bytes. So this 8 bytes will depend upon the computer architecture. So if it is a 64-bit machine, pointer size is 8 bytes. Now next, one more program to illustrate the use of pointers. So here we have seen, we are writing a program here to swap two integers using pointers. So by here we have used user defined functions. So this is a function, int main function here. We have initialized and declared two variables, a and b. So a value is equal to 100 and b value is equal to 200. Now what we want to do here is, we want to swap these two integers by using pointers. So we have written a user defined function here. So prototype for this user defined function is this one, function declaration or function prototype. This is the calling function. So in the calling function, we need to specify the name of the function. So name of the function is swap, and then the parameters. So these are the actual parameters. So there are two ways in which we can pass the parameters we have seen in the previous video lectures. So you can go through my previous video lecture, that is user defined functions in C. So there we have discussed in detail about actual arguments, then formal arguments and all, the concept of user defined functions. So here we are passing the address of the variable. So address of A and address of B. So we are passing the address of variables. So this is nothing but call by reference. So in call by reference, we pass the address of the variables. So now the control is transferred here. With this line, the control is transferred here. So after that function definition, all these statements will be executed. So here, name of the function and these values, these addresses are received by pointer variables. So these addresses are assigned to pointer variables. So now you can see here, this is a pointer variable. So any variable name which is preceded by star, so that is a pointer variable. So we have declared two pointer variables, x and y. So here we are declaring two pointer variables. Since this is an a and b are holding integer values, so therefore the data type of this pointer variable is also integer, since it is pointing to an integer value. So now suppose this is 1000, this is 2000. Now x is assigned the address of a, that is 1000, and with this statement, and y is assigned the address of b, that is 2000. Now we are actually working with pointers now. So inside this function, we have declared a variable, temporary variable temp. So it is empty. We have just declared it. We have not initialized it. Now here what we are doing is, we are assigning the value of, value at this particular address. So this is dereference operator. So with this dereference operator, we can actually work with the, or alter the variable values to which it is pointing to. Now this x is pointing to integer variable a. X is storing the address of a. So that is, it is pointing to integer value. So it is pointing to, this is pointing to integer value, whereas this is also pointing to integer value, that is B. So in A we have 100, B we have 200. So we can access the contents of this. So star X means, so we can analyze it in this way. Star X is storing the address of, X has the address of, X is nothing but X is equal to ampersand of A. So star of address of A is given by 1000. So value at this address. So this operator is also called as value at address operator. So value at this address. So value at this address is given by 100. So this is equal to 100. So this value is assigned to temp. So with this statement, temp is equal to 100. So this line corresponds to this one. So in temp we have 100. Now what about this line? So when this statement is executed, so what it means here is the contents of y. So the y is pointing to integer variable, that is b. Y is pointing to integer variable, that is b. So with this statement, what it is done here is star x is equal to star y. So star x means X is storing the address of A, whereas Y is storing the address of B. So value at this address, so value at 1000 is equal to value at 2000. So address of B is 2000. So value at this 2000 is, value at this address 2000 is 200. So 200 is assigned to this. Now 200 is assigned to the value at 200 is assigned to this address. So that is A. Now A value will become, so now A is equal to, so with this statement A is equal to 200. So A value is changed to 200 now. And then after that, so with this statement A is equal to 200. So after this temp value, so temp value we have 200, sorry, in temp we have the value of 100. So this value 100 is assigned to star y. So star y means y is pointing to this. So 100 is assigned to B now. So we can analyze it in this way. Star of, so y is nothing but address of B. So temp is equal to, temp value is 100. Now this 100 is assigned to the value which is there at address 2000. So in this way we can analyze it. So value at this address 2000 is 100. So that is 100. Now B is equal to 100. So in this way we can swap two integers A and B. So thus value at this 1000 is now 200 and value at this 2000 is now 100. So we are actually working with, so here in this program we have seen how to swap two integers by using pointers. Now similarly coming to the, so another concept of pointer, that is pointer to pointer. So pointer to, we can also declare a pointer to a pointer. That means that is, so here we will mainly discuss about double pointer. So it can be a double pointer, triple pointer or multi pointer and so on. So in this we will see some of the concepts of double pointer only. So we can store the address of, double pointer refers to, or pointer to pointer refers to storing the address of another pointer. So for example, consider the statements which are used for a double pointer here. Here int A is equal to 10. So A is equal to 10 means, so we have a variable A, its value is 10, and int star ptr is equal to ampersand of A. So declaration and initialization of the pointer. So ptr, so star ptr is now pointing to A. So A is integer value, so therefore its data type also will be integer. Now double star indicates that it is a double pointer. So double star, then name of the pointer is, name of the double pointer is dptr. So this is equal to ampersand of ptr. Now let us visualize this and then we'll analyze it with the help of one program. So here double star is used to declare the pointer to pointer. So that is a double pointer. So when we use double star here, this is a double pointer. Let us visualize it. What is a double pointer? So first what we have done is we have declared a pointer A. So sorry, we have declared a variable A value is equal to 10. So in A variable, so in the variable A value is equal to 10. So it will have some address. So that address is given by 2000. So address of A is equal to 1024. 1024. Now if PTR is pointing to A, it means PTR is pointing to A, so it means that PTR is pointing to A means PTR is storing the address of this. So now PTR value will be the address of A. So address of A is 1024. So PTR value will be 1024. So along with that in the memory, so memory is allocated for this PTR variable also. So that address is given by 2024. So this is the address of PTR. So double pointer here is, so we have declared a double pointer DPTR, which is storing the address of a pointer. So address of this is already a pointer. So address of this pointer is given by 2024. So it stores the address of this pointer it stores the address of this pointer PTR. So its address is 2024. So its value is DPTR value is 2024. Now let us visualize this. Double star DPTR. So double star DPTR is equal to, so star we can analyze it in this way. So DPR is nothing but, in the previous statement we have initialized with the address of PTR. So here DPTR is the address of PTR. So address of PTR is given by 2024. So this line 2024. So with this statement, so star this means at value at this particular address. So value at address 2024 is given by 1024. So that is given by this one. So value at this address 2024 is 1024. Now value at this address 1024. So this line indicates that value at this address 1024 is given by 10. So in this way, this is a double pointer which is pointing to PTR, So that is a pointer, and this in turn is pointing to a integer variable. So in this here, we have written a simple program to illustrate the use of double pointer. So hash include stdio.h. This is a header file. Then int main function we have used. This is a calling function. So here we have declared a variable a is equal to 10. So and then this is a single pointer, you can say. So star, depending upon this number of asterisks, so that will be so here we have only one star, so it is a single pointer. So star PTR is equal to ampersand a, and here this is a double pointer. So it is, the name of the pointer is preceded by two asterisk symbol or two stars, you can say, and this is assigned the address of PTR. So double pointer is a pointer to a pointer which is holding the address of another pointer. So address of A. So address A is a variable, it will have some address. So that address can be printed by the ampersand A. Suppose this is the address. So this value will, the output of this program is this one. So for this program, the output of this program is this. So these values can be different based upon the computer. So address is given by this. So address of A is this one. PTR is pointing to the address. So A is a variable. Its value is 10 and its address is given by 3131254404. And then PTR is a variable which is storing the address of A. PTR is pointing to this. That means it will store the address of this. So 3131254404. So this will have its own address. So now DPTR is pointing to the address. So DPTR is pointing to the address given by, so this address is nothing but 3131254392. So this address is nothing but the address of 31 PTR 3131254392. So this address, PTR address and DPTR value will be the same since DPTR is pointing to a pointer variable. So this is what it interprets. In this way we can visualize this output. PTR is pointing to A and DPTR is pointing to PTR. So therefore DPTR will hold the address of PTR and PTR will hold the address of A. So indirectly we can access the value of A by using PTR. We can access the value of A by using star PTR and also by using double star DPTR. So these are the two ways in which we can access the values of A. So PTR is pointing to the address PTR that is given by this. And then after that, pointing to address means this address. Then after that, in the next line, DPTR is pointing to the address. That means DPTR value. So this address. Then after that, value of A is given by A. A is equal to 10. So this A value, another way in which we can access this A value is star PTR. So that is star PTR. Another way in which we can access this value is double star DPTR. So in this way, this is an example program of double pointer. So now we'll discuss about the applications of pointers. So what are the different applications of pointers? First one is dynamic memory allocation. So this is used for, generally pointers are used for dynamic memory allocation. So in this way, memory wastage can be avoided. So instead of allocating the memory at compile time, so we can allocate the memory during runtime also. So that is the concept of dynamic memory allocation. So in detail, we'll see about this concept in our coming video lectures. So pointers are used to allocate memory dynamically using functions like malloc, calloc and realloc. So this will allow you to create data structures of varying sizes at runtime. So during runtime, memory can be allocated. So memory wastage is avoided. Passing parameters to functions. So we can pass pointers also. Pointers can be used to pass variables by reference to the functions. So we can pass the variables by reference to the functions. So in this way, we can actually change the values of the variables. So instead of creating a copy of the variables, we can actually work with the variables. So this enables the function to modify the original variable rather than working with a copy, which is the case with pass by value. So we have seen the example of swapping of two integers by using pointers. So there we are passing the address of the variables, and that address, we are passing the address of the variables. Then data structures. Pointers are essential for implementing data structures like linked list, trees, graphs and more. So these structures, they involve creating nodes or elements which hold both data and references to other nodes. Next, another application of pointers is string manipulation. So strings are nothing but array of characters, and manipulating them requires pointers. So functions like strcpy, strcat and strlen, they work with pointers to manipulate the strings. Next is function pointers. So we can also pass address of a function to another function. So we can also create pointers to functions. That means C allows you to create pointers to functions. That means we can also store the address of a function also. We can store the address of a function in a pointer. So this is particularly used for implementing callback mechanisms, creating extensible code, or dynamically selecting functions to be executed. Then pointer arithmetic. So this is mainly applicable for arrays. So when we are working with arrays, so in order to iterate through the array elements, so there we will see the concept of pointer arithmetic. Next is memory manipulation. So functions like memcpy, then memmove and memset, they use pointers to manipulate memory blocks. So these are the functions associated to manipulate the memory blocks. Then file handling. So pointers are used in file handling to efficiently read and write data from or to the files. Then accessing hardware. So pointers is a concept of low-level programming. So in low-level programming and embedded systems, pointers are used to access memory-mapped hardware registers directly. Next is pointers to pointers. So we can declare a pointer to a pointer. So that is what this pointer to pointer means. Pointers can point to other pointers. So this is useful when working with multi-level data structures or array of pointers. Next, memory optimization. So with the help of pointers, memory can be optimized. So pointers can help to optimize memory usage by avoiding the duplication of data and by enabling more efficient data manipulation. So these are some of the applications of pointers. So in the coming video lectures, we'll discuss about some more concepts of pointers, that is the different types of pointers, along with some examples. So until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.